Welcome intellectuals. In our today's video, we're going to go over exam questions on sets, because we want today to finish also this topic. We've been discussing about this topic for so long, so we're going to do questions. The first question, these questions are coming from tutorial sheet 2. Okay, and I selected question which you may be asked in your exam, so you must pay total attention to understand what I'll be doing here, because sometimes sets becomes so confusing, more especially in the questions which I've just chosen here. Okay, so we are going to start with this question. So the question is, write x is equal to negative 10, 10 about the brackets I'm going to explain soon. B the universal set, and x is equal to negative 1, 4, b 0, 9, c negative 3, 6, b the subsets of x. Find each of the following and display them on the linear line. Okay, so before I do anything here so far, I want to explain the brackets which you are seeing in the question. Okay, in the question there, you've seen this bracket which is looking like this. Okay, this bracket, you can call it in simpler term, it is an open bracket. Okay, this is an open bracket. Okay, what now do you need to know about this? Okay, you need to know that this bracket shows that the number is not included. Okay, it is not included, to mean it is not part of the solution set. Okay, whenever we'll be seeing this brackets, it will mean that that number is not part of the solution set. For example, in the universal set, it means to say negative 10 is not part of set x. This is what you should keep in your mind. What else do you need to know? Let's go ahead and talk about this bracket. Okay, this bracket, you can call it a bracket or a square bracket. This shows that this is showed a closed interval to show that the number is included. Okay, the number is included, the number is part of the solution set. Okay, you need to know this also. This is what you need to know without forgetting, as long as you be doing what? As long as you be doing mathematics at Mvungushi University or any other university you are quoting from. Okay, so whenever you see a number, for example, from the universal set, now we have, let's combine the two concepts. We have negative 10, okay, comma 10. What does this mean? It means that these numbers, they are ranging from any number, okay, from any number which may be greater than negative 10 but equal to 10. That means this set may run from the set x. Set x may run from negative 9, negative 8, negative 7, all the way up to 10. Okay, this is what we want to see. As you can see, in this set we have 10, but we don't have negative 10 because of this bracket. Okay, so these are some of the things that are going to help you to handle any question on sets when it comes to displaying sets on the linear line. So like the question is asking us to display a complement on the linear line, we also find a complement. So when you are dealing with sets on the linear line, the first thing, guys, you need to write the universal set there. Okay, you draw the universal set. This is our universal set. Now the universal set is running from negative 10 up to 10. So we're going to use now the brackets. Okay, we're going to use the brackets. Here we have open brackets, because set x is negative 10, 10. Okay, here we have a square bracket here. So you even name this to say this is our set x as the universal set. How are we going to find the a complement? A complement, guys, it is the set which is found when we remove a from the universal set. That is what we are. That's how we find the Hair complement. So we are going to remove A from the universal set. Our set A is -1, 4, and 4 are included. Okay, so this is what we are going to do. You must follow, guys, what I'll be doing here. So we're going to estimate our -1 can be here and our 4 can be here. So we're going to draw the line. This is our set X here, and we know that all are included there. You can even name it to be our set A. So here is the question. We want to remove set A from the universal set. So where is our A complement? It is the part which is going to remain after we remove A. So this segment is going to be removed. We are going to remain with this segment here. We are also going to remain with this segment. So we can even name this to be our hair complement. Also here, our A complement. Okay, so now, what brackets are we going to use? The brackets at the end we maintain. Even here we maintain. But I want to think of this, okay? What we need is A complement, okay? This is what we need, it is A complement. So we're going to stand at 1 because this is where our A complement, our first part of A complement is ending. It is at -1. Is -1, so we have set A here. So we're going to ask about 1. Is -1 part, is -1, let me do this. Is -1 a member of set A? Okay? So is -1 a member of set A? Actually, yes. Why? Because of this bracket which is showing that it is a member of. Okay, since it is a member of and it has been removed because we want A complement, that means that it is not going to be part of A complement. Okay, an example, guys, I can give here. Let's say, for example, let's say our universal set is 1, 2, and 3. Okay, and our set A is 1 and 2. Okay, and we are asked to find A complement. Here is what we do. A complement, guys, is going to be found after we remove 1 and 2 from the universal set. Let's say we have 3 here. So after we remove 1 and 2, we are going to have 3 here as our A complement. So this is the trick part. When we have -1 in A, it's not going to be part of A complement. Just as the way we have 1 and 2 here, it is not part of the hair complement. So since -1 is part of A, it's not going to be part of A complement. And to show that it's not part of A complement, we're going to use this bracket here to show that it's not part. So same applies to 4. Since it's part of A, it's not going to be part of A complement. This is how you show sets on the what? On the Leo line. So now to find A complement, the set itself, because there are two questions here. The first thing is to find the foreign set and display them on the Leo line. But I prefer displaying them on the Leo line first before we find the sets. Okay, so here is what you do. We are going to say A complement is starting from -10 all the way up to -1. So, and this is not included. Also, this part is not included. Okay, so at the end we use the brackets like the way it is. So here it is an open bracket here. Yeah, it's an open bracket. Where we are going to have a closed one, it is to this side. So we say union. Here, hair complement, it is at 4, 10. So this question I'm very slow, but I'll try to be fast to the other questions because I was trying to introduce a new concept to you. Because most of you, this is your new concept. So this is the answer to our question 1. Okay, let's go and do question 2. Question B, okay? Question B, we are going to find A intersection B. What you need to know about A intersection B is the set of elements which are found in both A and B. As usual, we are going to draw our universal set here. Okay, we draw our universal set. Is running from -10 all the way to 10 here included. So in set A we have, this is what I want you to be seeing. A we have -4, I mean -1, comma 4. In B, we have, in B we have 0, comma 9 there. Okay, this is what you need to be seeing here. So as you can see the numbers, we're going to write these numbers on the real line in order, in ascending order. So we're going to start from -1, 0, 4, then 9. So it is -1 here, 0, 4, and 9 here. Okay, so now what are we going to do, guys? Let's go ahead and draw the line for set A. Okay, let's draw a line for set A. We know that set A is running from 1 all the way to where our 4 is, and both are included. Okay, both are included. You can name this to be our set A. What about set B? Set B is running from 0 up to 9 there, and both are not included. We are following the brackets here. Okay, this is our set B. So we are going to look, intersection involves where the two lines are meeting. That's where our intersection part is, where the two lines are meeting. As you can see, the two lines are meeting at 0, also at 4 there. So our A intersection B complement, we're going to draw a line on top. Okay, this is going to be our A intersection B. Okay, now let's talk about now the brackets which we are going to use, because it's the only trick part. So we're going to say, since we are at 0 here, we're going to stand and say, is 0 a member of A? Okay, is 0 a member of A? So as you can see, 0 is between -1 and 4. If it is a number is in between a set, okay, it is within the interval, it means it is part of A. Okay, now we are going to ask, is 0 a member of B? Okay, is 0 a member of B? We are going to look now at the bracket which we have been given here, and we are going to conclude to say it is not part because of this bracket. So it is not part. Okay, now the question here, is 0 going to be a member of A intersection B? No. Why? Because A intersection B involves elements which are found in A and B. So since it's not going to be part, we are going to use the bracket here to show that it's not part. I'm trying to explain in the way, guys, that you should understand, even if you find it difficult with it. Let's now start at 4. Let's start for 4 here. We are going to ask a question. Is 4 a member of A? Okay? Because of this bracket, guys, for A, it is showing that yes, it is a member of A, it is included. What about 4? Is 4 a member of B, set B? Actually, 4 is in between set B there. Okay, it is within the interval, so it is a member of set B. Now, as you can see, is 4 now going to be a member of A intersection B? Actually, yes. Why? Because it is in both sets. So we're going to use the bracket here, the square bracket, to show that it is in both what? In both sets. Here, guys, is how you should be showing sets on the real line. By so doing, you've shown A intersection B there. So what is left now is just to write the set itself. We're going to say A intersection B is running from 0 all the way up to 4. The brackets, we use the brackets which are in A intersection B. We have this and this. Let's do A union B complement. I want to solve all the questions on this question 2. Then I'll give you question 3 as your what? As your assignment, which you are going to answer on your own. Then you are going to send me answers on WhatsApp. Okay. So for you maybe who may not know my WhatsApp number, this is my line. Okay, this is my line 0776369 then 666. This is my line. You can WhatsApp me on this number. Okay, what we do, we don't only teach mathematics, we also teach physics. Okay, you can ask me for physics, for chemistry and biology. So if you need help in these 4 courses, don't hesitate to WhatsApp me and we'll get back to you as soon as possible. Alright, so what is A intersection B? Okay, it's A union B complement. So as usual, we are going to have set A here. Okay, we're going to have set A, which is running from -1 all the way up to 4. Okay, we also have set B running from 0 then all the way to 9, both not included. As usual, we are going to draw our universal set there from -10 up to 10 there. Then since we are still using A and B in the question, we are going to have -1 here. We're going to have 0, 4 and 9. Okay, so what we are going to do now, we are going to draw set what? We are going to draw set A. Okay, this is what I want you to see. We are going to draw set A. Set A in this, let me just use white, and I'll start from here. Set A will be running from 1 all the way to where our 4 is. We are following the interval there, and both are included. We have set A here. Then set B starting from 0 up to 9, and both are not included there. Both are not included. This is our set B. So as you can see now, what they want is A union B complement. So uniting A union B complement, it is combining A and B. Where are the lines, the 2 lines covering? As you can see, the 2 lines are covering from this point all the way to this point. Okay, this is where the 2 lines are covering. So removing now A union B, because the question is A union B complement. So we are removing A union B from the universal set. So the part which is remaining here without being covered from A union B is this part, also this part. Okay, so what are we going to do now? Here is the question. What are we going to do? We are going to do this. At the end, we just use the brackets like the way they are here. Okay, this is our A union B complement, and also here is our A union B complement. So now let's talk about the brackets here. So since -1, okay, -1 is part of A union B because of this bracket. Okay, it is part of A union B, so it's not going to be part of what? A union B complement. So you change, when it comes to complement, you just change the bracket here. What about 9? As you can see, 9 is not part of B, and since it is not part of B, it is also not part of A, as you can see, because A hasn't reached where the 9 is. It means it is not going to be part of A union B. So removing A union B from the universal set is not going to affect 9 to be part of A union B complement. So here we are going to have to say 9 is going to be part of A union B complement. So this is how, guys, you should show this set on the what? On the real line. So what is going now to be done is just to write A union B complement here. Say A union B complement now is going to be equal to, we follow there these lines, they are starting from -10 all the way to -1, and both are not included. Okay, and both are not included here. So to combine the 2 sets, we say union. What about here, starting from 9 to 10 and both are included? So we are using these brackets here. In this case, we are using 9, 10 here. Guys, sets are very simple. You should just be reasoning. Okay, don't just jump. Let's do now question 4, which is the second from the last. Okay, so what we are going to do first, to handle this kind of a question, guys, we need to simplify something here. Okay, we need to do some simplification here. But I want you to be reminded to say that when you see a set, okay, when you see a set, just guys, some few seconds, okay. All right, I'm sorry, sorry for taking wrong. So here is what you are going to do. We are going to simplify the set. We want to simplify this set so that we won't struggle when it comes to presenting it on the level line. So the set is A intersection B minus C complement here. Then we have a complement A. Okay. So here is what I want to show. For those who watched the video on when I was explaining about laws of set theory, you need to know that when you have A minus B there, it is same as A relative complement of B. Okay, and this is same as A intersection B complement. You need to know this. It is same as A intersection B complement. So I want you to look at this and this, because in this case it's the part where I'm interested. Okay, when you see this part and this part, they are in the same form. Okay, they are in the same form. As you can see, there is a set and we have a set raised to a complement and an intersection in between. This is exactly what we have here. So we can simplify this set back to this set by removing the complement here. We remove the complement and the intersection is replaced by a minus sign. Okay, so what we are going to do here, we are going to have our hair. Now here we are going to have a minus and the complement is going to be removed as usual. As you can see here, the complement has been removed and the intersection has been replaced by what? By negative there. So we are going to have B minus C complement here. Okay, what else? What can we simplify? What further simplification can we make? Let's try to look about what is inside here. What is inside? Inside we have B minus C complement there. Okay, you should look carefully here when it comes to simplifying sets. Okay, what do we do to remove the minus, guys? To remove the minus, we are going to say, to remove the minus, we are going to have B. We are going to replace an intersection. This is how we removed the minus here. We're going to replace an intersection. Then we're going to add a complement to B. As you can see, we had no complement at this point, but because we've removed a minus and replaced by an intersection, we're going a complement was added. So we're going to have C complement. Now, since we have already another complement, so we're going to add another complement. And I was saying that a complement of a complement set of a complement set, it is already the same set. So if you have C complement, it is actually C. This is what you need to know. So this is how you simplify this set. Okay, if you don't understand, you can pause the video and try to play back. That's how we understand videos. So this part now is going to be replaced by B intersection C. So I'm going to have A minus B intersection C there. Okay, it is not bad, guys. It is not bad for me now to write B intersection C complement. No, or let me just end here so that I may not confuse you more. Let's go and display now this set on the real line. Okay, as usual, we're going to draw our universal set. We're going to draw our universal set running from this point all the way to -10 there. This is our universal set. Now in this sense, we are using all the elements in A, B and C. Okay, so there must be some difference. So we have -3 as the smallest there. We have -3 there. What else do we have? we have a negative 1, because negative 1 is bigger than negative 3. We have negative 1 there. Then we are going to have 0, else it is 4. We have now 6 in set C, then 9 in set B. Okay, so we are going to be drawing. Our first thing is to find the B intersection C. Okay, or let's start with A. Okay, let's start with A. Here is what you should be seeing, guys. I'm going to just write everything in this part. Okay, but as for you, you need to be clear. I'm also going to be clear. Let me just also be clear. I should read by an example. So what we are going to do, guys, we're going to draw our set. Let me use any other color. We are going to draw our set A. Set A is running from negative 1 to 4, where there is 4 is, and both are included. This is our set A. What about our B intersection C? Okay, let's go ahead and draw our B intersection C. Okay, here is what you need to see. So in fact, to understand this, they are telling you that write A by removing B intersection C. Okay, we write A by removing, minus is showing we remove B intersection C from set A. So what we are going to do now, we are going to draw our set B. Set B is running from 0 all the way to where 9 is. Okay, this is our set B here, and both not included. What about set C? Set C is running from negative 3 to where 6 is, and the negative 3 is included, but C is not included. This is our set C. Okay, so now I want you to understand this. Okay, I want you to understand this. Our first thing is to find B intersection C. Okay, our first thing is to find B intersection C. Okay, I want you to not to be confused too much. Let's find B intersection C. As you can see, the lines are meeting here, also here, there. This is where our B intersection C is. This is where our B intersection C is. So let's now look about the brackets which we are going to use. So since we are standing at 0, is 0 part of B? No. Since it is not in one of the sets, it is not going to be part of the intersection. Okay, is 4 part of B? Yes, because it is in between B and it is also in between C. So it is in both sets. It is part of the intersection. But the question, guys, is asking us to show B A minus B intersection C. So what we just have, keep in mind to say that our B intersection C is running from 0, 4 here, which is included this part. Okay, also this part. Okay, because I'm going to erase something here so that we may understand better now. Okay, guys, the sets are very simple. I don't know why you people you are finding difficulties with sets. You just be following all the steps like the way I'm explaining here. So this is the only the longest question we have. The rest will be short questions. I wanted to leave one of the questions here for you, but I'll ask you to go and do question 3. Now understand this, guys. What we want, okay, let me redraw our universal set. This is our universal set now. Okay, this is our universal set, our set X here, and we have set A is running from -1 up to where our 4 is. Okay, up to where our 4 is. Okay, this is our set A. Now our B intersection C complement. Our B intersection C complement is running from 0. Okay, it is running from 0 up to 4. Okay, it is running from, so we can put 0 here. So our B intersection C is running to this point. This is how you show sets now. It's an interesting part of this set. So this is where our B intersection C is. Okay, this is where our B intersection C is, and here it is not included, but here it is included, and A is included everywhere. Our A is everywhere included. So the question was to find A, okay, to find A minus B intersection C. So they are telling us from our set A here, let's remove B intersection C. Which segment is going to remain, guys? Actually, it is this part. Okay, it is this part which is going to remain. So we are going even to write our line on top now to show that this is our A minus B intersection C. This is our A minus B intersection C. Like the way I'm showing things here, guys, it's how we should show this. Okay, so at the end we have the square bracket here, but here where the two lines are meeting, we must understand something. Okay, 0 is part of A. Okay, 0 is part of A, as you can see here. 0 is part of A, but it is not part of B intersection C because of this bracket. So even if we remove B intersection C, since it is not part of B intersection C, it is still going to remain in this set, which is our set A. So it is going to remain in this set. Okay, as simple as this. So what is going to be now our this set? Our this set now is going to be, so to find now the set A minus B intersection C, here is what you are going to do. You are going to say it is running from -1 and both included up to where our 0 is. Okay, up to where our 0 is. So this is how you show this kind of sets. Let's go ahead now and do the last question. Our last question is question 5. Let me check if I left a space here. Okay, there is still a space here. So guys, let me go ahead and simplify this part. Okay, because this part is already simplified. This is same as A complement. No one can got confused. X minus A. They are saying remove A from the universal set here, which is same as A complement. So let's go ahead. I want to simplify this. Okay, you guys, what I want you to apply is the concept of A minus B is equal to A intersection B complement. This concept is very important. Like I said, you miss it, you miss everything about simplifying set and displaying them on the liu line. So since this is same as to this, okay, so what you are going to do, this part is going to be written as this. Okay, so we're going to have A intersection B complement. Okay, what about this part? This part now, since we are going to remove a minus and we had a complement here, okay, we are going to remove a minus and we had a complement. That means we are going to have an intersection here. So because when we remove a minus, we must add an intersection, and we had a complement here. Okay, this is what you have been doing. So a complement and a complement will cancel. Okay, so this is the set now we are going to display on the liu line. So our simplified set becomes X minus A union A minus B minus C complement there. Okay, so first of all, I'm going to display this set on the little line. Then we are going to unite at the end. Okay, so I'm going to write I'm going to write my universal set to be here. Okay, let me write my universal set to be here. My universal set to be here, running from -10 all the way up to 10. Since we have A and B and C, our number will start from -3, -1. I'm following the numbers which are there, and we did this kind of a question which similar to this, which involves the three sets. And we're going to have 0, 4, 6, and 9. Okay, what is our set A? Our set A is running from 1 all the way to where 4 is. Okay, from 1 all the way to where our 4 is. What about our B? Our set B is running from 0. Okay, is running from 0 all the way to 9, and both are not included. From 0 all the way to 9, and both are not included. Okay, all right. So when it comes to B, what we want here, we have A. Yes, it is what we want, but B is not what we want. We want B complement. Okay, so our B complement now will be the segment which is going to remain after we remove a B from the universal set. So as usual, this segment is going to run from here. Let me try to change the color, maybe it's going to make some sense. So this will run from here all the way to this point, also from here all the way to this point. Okay, and this point will remain like the way it is. Also this point is going to remain like the way it is. This is our B complement. Also here, this is our B complement. Okay, now to decide, we are going to find the B complement, we just change the signs here. Okay, we just change the brackets. So here we're going to have this bracket. Since we have this here, we're going to have here for B complement this bracket. As simple as that. So let's go ahead and draw now set C, because it's the one which we've remained with. Set C is running from -3 all the way to 6. Okay, I can draw it from here, -3 all the way to where our 6 is, and 6 is not included, and 3 is included. So now, where is this set? Where is this set? Okay, where is our this set we are looking for? Okay, so it is the set where A and B complement and C are meeting, because we have intersection there everywhere. So as you can see, this part, we have our set C here, our set A here, and our B complement here, and our B complement here. So what you are going to do, these three lines are meeting here. As you can see, they are meeting at this point. They are also meeting at this point. This is where the three lines are meeting. Okay, we don't have a line which is meeting. As you can see, we only have B complement. Okay, we forget about B. We are dealing with B complement. It is which is in the question. I just included it so that it may help us to find our B complement. So you can see that this B complement is just around here. Even here, we have the line which are meeting. We only have B complement and A, but C is not there. So the only segment where the three lines are meeting, it is at this point. Okay, it is at this point. So at this point, you can draw now a line on top to show the lines where they are meeting is our A intersection B complement intersection C. Okay, let's now discuss about the bracket which we are going to use. Let's talk about -1. Okay, let's talk about -1, because a complement of both sets, it's a number which must be found in both sets. Okay, -1 is -1 part of C. Yes, why? Because -1 is between set C here. Set C is running from here all the way up to here, so it is part of set C. What about A? Is it part of is negative 1 part of A? Yes, because of the bracket here, which is indicating it is part of A. What about B complement? Is it part of B complement? Also yes, because it is in between our B complement here. So the bracket we are going to use for negative 1 is this, because it is in both sets. We stand here. As you can see, 0 also is in between set C, so it is part of C. It is also in between set A, so it is part of A. And also for B complement, it is part of B complement because of this bracket. So I'm also going to use this bracket. Okay, so this is our A intersection B. So our A intersection B complement intersection C is all the way from negative 1 and both included up to 0 also included. Okay, what else do you need to know now? We've just found our A intersection B complement intersection C. Let's go ahead and now deal with this part. Okay, let's go ahead and deal with X minus A, because what we want to find is not only this part. Okay, we want to also to find X minus A so that we may combine the two. It is very simple. Let's do this, guys. Let's do this. So we are drawing the line. Okay, we are drawing the line of our universal set as usual. The universal set as usual, we draw it. The universal set is running from negative 10 all the way to where our 10 is. Okay, so what we are going to do, guys, we are going to draw our first. We can draw in this set. We have negative 1 and 0, and in A we have negative 1 and 4. So I'm going to include here negative 1. We have 0. We also have 4 here. Okay, so I want you to see this. Let's recall this. I want you to understand this step by step. That's why I'm going to be slow here. What is our X minus A? First, we are going to draw our set A there. We draw our set A. This is our set A, guys. What is our X minus A? It means remove set A from the X, which is the universal set. So that our X minus A is same as that A complement we draw. It is going to be here. This is our X minus A. Also, this part is going to be our X minus A. It is the part which is remaining after we remove set A. And the brackets, as usual, as the one I used, guys. Just recall from what I explained here. Okay, now let's draw now, because we want to unite X minus A with this set. Okay, let's draw now our A intersection B complement intersection C. It is running from negative 1 here. It is running from negative 1 all the way to where our 0 is. It is running from negative 1 all the way to where our 0 is. And this part is included in here, and also 0 is included. This is our A intersection B complement, then intersection C. Okay, now to find the set which you have been given now, because this is now how you display on the level line. Okay, this is how you display on the level line. Now to find the sets, okay, let's go ahead and find the set. We say X minus A union, guys, it's combining the sets minus C complement there. So this set now, we are going to start with X minus A there. X minus A is running from negative 10 all the way to negative 1, and both are not included. Then in A, we are going to unite. That's how we combine it. We are going to unite this set, which is running from negative 1 all the way up to 0, also included. Then we combine with this set, which is running from 0 all the way to 10. Okay, all the way to 10. Actually, this part is not included here for x minus a, which is at the end. So this is how you find the set. Guys, you need to pay attention when it comes to set displaying them on the Leo line. It's not that simple as you can think, but it becomes so interesting when you just familiarize yourself with what I was doing. The key point I can give, guys, know how to use these brackets. Okay, once you know them, know the operation of sets, what A intersection B means, what is A union B means, and what a complement of a set mean on the Leo line. By so doing, then you'll be okay with dealing with any question. Okay, so this part you can be showing when you are asking the exam, you can be showing all the steps I was showing there. Then your final answer should be this part. Okay, this is how you display now the set on the Leo line, and the answer now should be this one. Okay, so this is the question now I asked you to go and try. Okay, go and try and send me the answers. I want you to see how far you can apply then your understanding. Okay, so I want to, guys, when I give you questions to give me the answers, I only see about maybe 7 or 10 people bring me back answers. I don't know why you guys others you've been reluctant to submitting your work, which I always give you. Okay, so let's go and do this question. For each of the following sets, in fact, this question I also solved in the video lesson which we had on the infinite and the finite sets. Okay, so the only thing I can remind you of is that an infinite set, it is a set which has we can't count. It has countless. Okay, it has countless members. We can't count the members of that element, and the opposite of that is a finite set. Okay, finite set contains countable numbers of elements we can count. So now, as you can see for set B, is set B a finite or an infinite set? When you have a number, there is a limit. They are saying from 1 up to 100. We can count these numbers, okay? We can count these numbers. So our B is a finite set, okay? Let's talk about set B. That set B, I want you to understand this, okay? I want you to understand this. Okay, so what we are going to do is this. For set B, we can either just understand by writing what the set really means, or we also display them on the Leo line. So I'm going to show you both ways of handling the question. So the first thing, guys, we are going to find this part. Okay, what is our 0,1 mean? It means are the numbers which are what are starting from 0 up to what are starting from 0 up to 1. Okay, starting from 0 up to 1, because both are included. So these numbers can be 0, 0.1, all the way up to 1. Okay, but this number is telling us to start from 4 over 3. So what is 4 over 3? 4 over 3 is actually 1.3. Is 1.3 all the way to a number which is less than 3 point what? 3 over 2. 3 over 2. Why am I saying a number which is less than 3 over 2? It is 3 over 2 is 1.5. So we're going to take maybe 1.4 there. Why am I saying 1.5 is not going to be part of the solution set? It is because of this bracket which they use. Okay, which they use. So even here we can have maybe 1.4 here, 1.31, 1.34. That is going to make sense. So as you can see now, let's find the intersection. We can't have a number which is found in these two sets. We can't have. In fact, we don't have that number which is found in both sets. So the answer to this set is an empty set, okay? And we know that an empty set is a finite set. So our set C is a finite set because we don't have any number which is in these two sets. The other way you can present this set on the Leo line, you can say, let's say our university be a set of numbers from negative infinity, a set of real numbers to positive infinity there, okay, to positive infinity. And we're going to draw our set which is coming from 0 here, can have 0 up to 1 there. Okay, we are going to draw this set. Can rate this set to be set A, okay. What about 4 over 3? I said 4 over 3 is 1.3, so 1.3 can be somewhere here, okay. We draw this set all the way to 1.5 there. 3 over 2 is 1.5, okay, and both are not included. So because of an intersection here, they are telling us find the region where the two lines are meeting. Do we have the region where two lines are meeting here? Actually, no. That's why there is no region where the two lines are meeting, and this is what we call an empty set. This is what I meant here, guys. So, and an empty set, as usual, is always a finite set, because we can count the number of elements which are in the empty set, and those numbers are just 0. This is how you handle this kind of equation, guys, as simple as that, okay. Now let me jump to question A, to set A, because set G has got something which okay, if you may be lucky, I'll answer. If I may not be lucky, if you may not be lucky, I'll just show you what it means, because this question is going to take me a lot of time. I'll teach you how to solve inequalities, okay, how to solve inequalities. Now let's talk about this number x, the modulus. When you see this, they are meaning the modulus of x minus a. The modulus is a distance between 2 points on the real line. So guys, a distance here, you have never heard about -2 kilometer. You won't find this can never be true. There is no distance which can be negative. The distance is always positive. So when you see a modulus here, I'll teach you more about modulus functions very soon when you are going to start functions, because it will be our next topic after SADS. So the modulus of any number is always positive, okay. We can't put a number inside the modulus and have a negative. It can't be true. It can't happen, because the modulus is always positive. So let's look about this. After they put x minus a, they found to be negative. This is not true. Why? Because the modulus of any number is always positive. Now, since that we have a negative here outside, it means to say that this set A is just an empty set. Why? Because we don't have any value of x which we can put here to have a -1 here, okay. And this is true. Let's try to say we put a we put our value to be of x to be -2 minus 1, okay. Although this number can give us -3, because it is inside the modulus, the answer is going to be produced will be 3. I'll teach you more about this. So from now, just understand to say that we can't have a number inside the modulus which can give us a negative. So because this is contradicting the fact of the modulus functions, it means to say that the set A is an empty set, to mean that we don't have that number which we can put inside x there to have -1. So it is an empty set, and an empty set is a finite set, okay. So even our set A is a finite set. So let me talk about set J. I think maybe you'll be lucky. About set B, understand this. Set B, we have been given to say it is a set of x where x is squared plus x is 2. Actually, this, guys, is an infinite set. Yeah, it has an infinite set. We can't count the number of elements which are greater than this, but okay, let me just show you. I feel like showing you. Okay, here is what we are going to do. We are going to solve this inequality. We're going to take this to the other side. We're going to have x squared. We're going to have x squared plus x. Then this is going to be minus 0. What are those two numbers? This is a quadratic function, guys. Now, two numbers which we can multiply to have -2, because our product is -2, and our sum is 1 here. Okay, those two numbers we can multiply to have -2, and we had to have 1. I see those are what we are calling now factors. Okay, are going to be factors. So I choose to be 2 and -1, because when we multiply the two, we're going to have -2, and when we had, we're going to have 1. So we're going to replace. We're going to have x squared minus x plus 2x there. Minus 2 is less than 0. So next is just to simplify now, I mean to factorize by parts. We're going to say x there is common. We're going to have x minus 1 there. Then plus 2 is common. So we're going to remain with x minus 1 is less than 0. So we're going to, this is going to be, we're going to make one bracket here. It's minus 1, sorry. Then what is outside, you have x plus 2 to be less than 0. Okay, so here is now where our part comes into effect. So we're going to find what we call critical values. So we're going to equate what is in the bracket to what? To 0. So we have x minus 1 here, going to equate to 0, and this will give us x is equal to 1. What about you have x plus 2 is equal to 0? What is going to have is x is equal to -2. Okay, now let's try to take this on the level line, because these are not the answers, guys. Okay, on inequalities we call this to be our critical values. These are our critical values, which we are going to use to find now the solutions at which we are looking for. So we're going to draw the level line. This is how you draw the level line. Okay, we're going to draw the level line. Okay, we are going to do this. We are going to run from -infinity all the way up to +infinity. Okay, so now we are going to write this on the level line. We are going to have -2 here. We also have our 1 here. Okay, so as you can see now, we have 3 intervals. The first interval, it is this. Okay, the first interval is running from -infinity all the way to -2, and the second interval is running from -2 up to 1, and our third interval is running from 1 all the way up to +infinity. Okay, so what we are going to do, guys, we are going to be choosing a number. Okay, a number within this interval. So a number which is between -infinity and -1, I can talk to be -3 there. Okay, so we're going to replace -3 in this equation. While there is x, we put -3. So we are going to have -3 minus 1 there, multiplied by -3 plus 2. Okay, then our condition is less than 0 there. Okay, I mean greater than 0. So -3 minus 1, we are going to have -4 there, multiplied by, we are multiplying now by -3 plus 2, it is -1, greater than 0. So -4 times -1, you're going to have 4 there to be greater than 0. Okay, so we're going to ask, is 4 greater than 0? Yes. So this, we are going to take this as our part of our answer. So we have checked the interval, it is valid. Let's try to check the interval which is in between here. As usual, we are going to take a number which is between -2 and 0. Guys, you should take note of what I'm saying here. You are going to apply them very soon. Okay, x is equal to 0. I choose just a simple number which is between -2 and 1. It is 0. So I'm going to replace where there is x, I put 0 there. So it's 0 minus 1 there. Okay, multiplied by 0 plus 2 to be greater than 0 there. So I'm going to remain with -1 multiplied by 2. And our answer is going to be -2 here. We're going to have -2 is greater than 0. So as you can see, is -2 greater than 0? No, because all negatives are less than 0. So this is not true. So this part is not true. Let's go to a number which is between -1 all the way up to +infinity. The number which is in between, I can take the smallest number, it is 2. So I'm going to replace, while there is x, we put +2 there, minus 1, then multiply by 2 plus 2 there. Okay, to be greater than 0 as our condition is. So 2 minus 1 is 1, 2 times plus 2 is 4. Okay, we're going to have greater than 0. So 1 times 4, we're going to have 4 is greater than 0. Is 4 greater than 0? Yes. So this is a valid Okay, so our interval now, our answer of x is going to be now, this is negative infinity, negative 2, union we combine with now the other one which is valid, 1 comma infinity. As you can see, we have infinities in this in this set. So this set, we can't count the all elements which are in this set. So this is an infinite set. I think I've already taught you about inequalities. You won't learn, guys. Okay. This is question 5. Venn diagrams. I answered this question in the other video. Okay. I want us to do this question. Although this question I'm only going to answer. Okay. I'm going to answer a few questions from here. Okay. So the question is, in each of the following diagrams given below, shade each of the following separately. Okay. So what I'm going to do is this. I'm going to do this question. I also do this question. What else can I do? I'm only going to do 3 questions here. I'm also going to do this one for union. This one for union. Yes. Okay. So the question is to shade all the sets in the Venn diagram which have been given. So what is this x? X, the relative complement of y, is same as x minus y. They are telling us shade set A. Okay, shade set x. As you can see, set x, our set x is this. Okay, our set x is this. This is all about our set x. Okay, so this is all about our set x. Going to suffer too much if this is going to continue. This is our set x, guys. This is our set x. Okay, I want you to see this. This is our set x, but we have been told to say remove the segment of y from set x. This is what it means. So it means to say the remaining part we are going to shade is only this, guys. It is only this. We are going to remove the segment of y. Okay, let's try to remove the segment of y there. Let me reach the segment of y. So the segment of y, it is this part now. We are going to remove the segment of y because we don't want the segment of y from set A. So the remaining part, okay, the remaining part now is our what? Is our x minus y. It's like we are removing y from set x. This is what we were doing. Let's also draw here. So even here, guys, it will be also very simple. X minus y in this set, it is like, you know, x is the big set here. It is running from here all the way to here. And we are removing it from set x. So the part which is remaining for x is this. It is this part. It is the part which is remaining. Okay? It is the part which is remaining. This is how you draw now this kind of a set. Okay? This is how you draw this kind of a set. So, or what I'm going to do, let me skip this because I'm going to suffer too much. The slides I prepared will allow me to be, won't be allowing me to proceed to other questions. It will give me pressure to be raising everything, and you know, my PC is very low by now. So let me just go and do this other question. After the video, I'm going to charge the PC and I'm going to answer this question in full. Okay. So let me do this question because this question doesn't require to shade. It is just requiring to describe the shaded region. Okay. how can we draw the shaded, how can we describe the shaded region here? Okay, how can you draw the shaded region? As you can see here, we have two sets here. Okay, we have two sets. I want you to understand this. We have set B, we also have set A. Okay, so that means, as you can see, they were about to shade the O of set B. Okay, the O of set B, but they have removed this part of set B, which is a part which is also involved what? Involved part A. So how can we describe this part? This is B, a relative complement of A. It's like B minus A. Okay, we can write this as B minus A, or as I was explaining, B intersection A complement. Okay, B intersection A complement. We have removed B. Okay, we have removed A from set B. This is what it means. Okay, our set B supposed to be everything, but since A is also touching this part, it has been removed, and we are going to remain with what? With the set B there. This is how you describe this set. Let's go and do set this too. How can you describe this part? Okay, this is also very interesting. Okay, this is very interesting. I want you to see this, guys. The shaded region. Okay, the shaded region, as you can see, it's like the only part which has not been shaded. It is A. Okay, it is A which has not been shaded. We have A as the one which is not shaded. So outside A, outside A, when A is not shaded, it means it is A complement. Okay, when A is not shaded, it is A complement. But let's look at this. There is a part of A which is shaded, and this part of A which is shaded, it is an intersection of both A and B. Okay, it is an intersection of two sets A intersection B. It has been shaded. Okay, so what I mean is this, guys. Having problem with here. When we have set A here, and the outside is shaded, the outside is shaded, it is A complement, and as you can see here, the outside is all shaded. The outside of A is all shaded, so that part is A complement. Okay, but there is also another part of A which is shaded. Okay, and that part is A intersection B. So we're going to combine A complement there. Okay, to describe the full now, the full set which has been shaded. It is A complement, it is shaded. Also the A intersection B, it is also shaded. So to combine it, we are going to have A union A intersection B. Okay, this is how you describe this set. What about this question? Okay, what about this question? Here it is an interesting part. As you can see, A and B are not shaded. Okay, so A union B are not shaded. Because they are not shaded, it's to mean they are removed. Okay, they are removed. So A union B complement. So A union B complement is what has been shaded. A union B is not shaded. Like I was saying about A here is the one which is not shaded. So the part which was shaded is A complement. Okay, then we combine with the part of A which was shaded. This is what you need to understand here. So A and B are not shaded. So the part which is shaded is A union B complement. Okay, it is A union B complement. What about the part of A? And you can say that there is a part of A and B which has been shaded, and this part is this. Okay, it is the part which has been shaded. So this part also is A intersection B. Okay, so to combine the two, how can you do? You just unite. So this is the whole set which has been shaded. Very simple about shading sets. Okay, this is the last part of this question, also the most important part of this question, together with the first question we were doing. So like I always emphasize, if you are watching a wrong video, take a pause, you rest, talk to your friends for 10 minutes, you hit a cup of tea, then or hotter. It's really help. It's a very refreshment. It's a very good refreshment. You can drink hotter for 10 minutes, then you get back to watch the video. So the first question A. Okay, given that P and Q are disjoint sets, simplify P complement union Q complement there. The fact you need to know about disjoint sets. Disjoint sets have no intersection. Okay, if we have been given P intersection Q, okay, they have no intersection. That means P intersection Q will be an empty set. Okay, this is the symbol for an empty set. So whenever you see two disjoint sets guys have no intersection. On the number line, on the Venn diagram, you can represent this to be this. Okay, sets which are not meeting, P and Q, they are not meeting, they have no intersection. These are disjoint sets. I explained this for those who watched that video. Okay, so what we are going to do now, what are you going to do? You are going to say P complement union Q complement. Now when you look at this is actually De Morgan's law, guys. De Morgan's law states simplifies two complements which are uniting. Okay, we have if we have A complement union B complement there, it is same as, you need to know this, take note of this, it's same as A intersection B complement. Okay, same applies when we have A complement intersection B complement. It is same as, now we are going to have A union B complement. This is what it means, guys. So when you see two complements are uniting or are intersecting, apply De Morgan's law. Okay, this is De Morgan's law, guys. De Morgan's law. These are De Morgan's laws of sets. Okay, so this part and this part, as you can see, they are one and the same. So it is same as we are going to write as A intersection B complement. So this can be written as P intersection Q complement there. Okay, P intersection Q complement. We are converting this. We are writing this in this form. Okay, so P intersection Q complement. But what do we know about P intersection Q, guys? Okay, P intersection Q, since these two are disjoint sets, it is an empty set. Okay, so where there is P intersection Q, are going to replace an empty set and a complement. Identity laws states that the complement of an empty set is the universal set. So the answer is going to be the universal set there. Simplifying sets, guys. Let's do question B now. We have X complement intersection X union, we have union Y there, we have Y, then complement here. So here's how we are going to do about it. This, as you can see, this using De Morgan's law. De Morgan's law states that A intersection B complement is the same as A union. Let me put union here. Okay, is same as A complement intersection B complement. This is what I was talking about. Know these laws, guys, and the other one I was talking about. So from this, I'm sorry, guys. Okay, so here is what we are going to do now. Sorry for the disturbance, I'm really disturbed. So here is what we are going to do. we are applying De Morgan's law. Okay, we are applying De Morgan's law. All right, so what are you going to do is simple. It is just simple. This is what we are doing. Okay, I really disturbed. Okay, so this is same as this. Okay, so this part x union y can also be written as x complement intersection y complement according to De Morgan's law. Then we combine the part which has remained here. Now I want to look at this, guys. I want you to look at this. Okay, x complement intersection x complement. Okay, x complement intersection x complement. So when you are intersecting two sets, the answer is the same set. Very simple. You need to know that those laws, intersecting the same set, the answer is the same set. So x complement intersection x complement, we're going to have x complement intersection y complement. And this now using De Morgan's law can be written back to x union y complement. As simple as this. Let's do question 2. This question summarizes all the laws. Now, let's talk about distributive law. Distributive law, guys, talks about how sets multiply out. Okay? So let's say, for example, we have A intersection B. A intersection B union C there. So how do this multiply out? This is like multiplication. We are going to multiply A intersection B times B. Okay? We are going to have A intersection B there. Okay? Else, it is A times C. A intersection B times C. We are going to have A intersection C. Okay, now in between here, we are going to replace the sign which is between here. It is union. This is what distributive law states. So it is same as if you had A union B there. B intersection C. It is same. We are going to multiply A union B there. Say A union B. Then in between here, we are going to replace an intersection. Then we have A union C. Simple. So as you can see this question, we have X intersection everywhere. That means to say that we can write this part. As you can see this part, it is in this form. Okay, it is in this form. So we can write our A intersection. Our A intersection was what was factorized out. That's why you have A intersection B here. So this is common, guys. This is common. So we can factor it out. We're going to have X intersection there. Okay. So here we're going to remain with Y. In between we have U there. Okay. Then we have Y complements here. X and X will cancel. X intersection and X intersection will cancel. Going to have Y complement there. Okay. So even here I'm not going to do all the question. I'll leave some for you. I'll leave some for you. More especially, I'll leave for you the last question. Though it is looking to be complicated, I'm going to show you how very simple it is. Okay. So what is the Y and G? When you are uniting a set with its complement. These are some of the rules you need to know. With its complement, A union A complement, the answer is the universal set. Okay, let me try maybe to give you an example. You guys, you may understand maybe using examples. Let's say we have our universal set, which is running from 1, 2, and 3. And we have our set A. Our set A is 2. So our A complement, we are going to remove 2 from the universal set. We are going to remain with 1 and 3. Okay, so let's find now A union A complement. We are going to combine these two numbers, these two sets. Okay, we are going to have 1, 2, and 3. And this set is same as the universal set here. So when you are uniting two sets, guys, a complement and its set, we just have the universal set. So here we're going to have the universal set. And the other rule you need to know is that when you are intersecting a set with the universal set, the answer is that set. Just know this, guys. Okay, I want you to take note of this answer. Okay, I want you to take note of this answer. It is very, very important for this question. Let me even write it here. So this, we have x. There is a reason I'm saying we should take note of this. So even here we have x as our this answer. We go ahead. I want to even here we have x as our answer here. There is because this question has been repeated many times. That's why I'm saying we keep that answer. So let's do this question now. What is our x complement intersection y complement there? Okay, so using De Morgan's law is going to change these two x union y and the complement outside. Okay, now since we already have another complement here outside, we are going to multiply this by a complement, and we know that the complement and the complement are going to cancel out, so we're going to remain with x union y, okay, as our answer. Very simple. So guys, without knowing the laws, so before you watch this video, I kindly beg you to go and watch back the video on laws of set theory. I explained that video. If you don't have, you request it from me so that I send it to you. Okay, let's do now this question. Okay, it is the last question because this question and this question are one and the same. They just repeated. So I'm going to do this question, and this question you do it on your own. The reason is very simple. I'm going to show you why you are going to do that on your own. Okay, I'm going to answer it also. I'm going to answer it. Okay, I'll answer it. Okay, let's do this question. So from here, first we have these brackets here. We have these brackets here, and we have something inside. So let's try to do with what is inside. Inside we have x intersection y there, union x, the complement over y there, the relative complement of y there. This is what we have inside. Okay, this is what we have inside. So here is what we are going to do, guys. Writing this, okay, writing this is same as in that form. I was saying that I was saying a is same as a intersection b complement. You should remember this. Okay, so even here it is same as we're going to write x intersection y union x intersection y complement. Okay, now I want you to see this. What is the difference between this and this? There is no difference actually. So I'm going to replace this with x because this is the answer we found. Okay, I'm going to replace whatever is inside with x, and outside we have a complement, so the answer is x complement. Very simple, guys, very simple. So let's do now this question. As you can see now, let's look at this part from here all the way to here. Okay, from here all the way to here, it is this same part. Okay, this is how tricky this question was. Okay, you just see. So this part, guys, is going to be replaced by x. I'm going to replace that by x. Then I say union this part, x union x complement intersection y. So how are we going to simplify this now? We're going to multiply out using distributive law. So distributive law will help us now. X union, this is x complement, okay. Then here in between of intersection, then x union y there. What can we do? Is simple now. When you guys, I was saying that when you are uniting a set and its complement, the answer is the universal set. So x union x complement, the answer is the universal set. Intersection x union y. Okay, what else do you need to know? Intersecting a set with the universal set, the answer is the set itself. So the answer is x union y. So guys, this is the end of our today's video. If you find the video helpful, you guys who have not yet registered to our tuitions, please inbox me on this number. We will really help you. Okay, this is my number. Inbox me so that you register. We help you clear physics, mathematics, biology, and chemistry. So thank you for watching. For more videos like this, subscribe to the channel. You like the video, you also hit the notification button so that you may not miss out new uploaded videos, because though I don't upload a number of videos, I upload sometimes, okay, because my videos are mostly shared to students who are registered with our tuitions.